this video, we have a 2D projectile motion problem where an object is dropped from a moving plane. Have a small plane that drops a package while it's flying in the horizontal direction at a velocity of 152 meters per second. If the plane is 2,100 meters above ground, how long is the package in the air and how far away does it land horizontally? So let's go ahead and draw out what this would look like. So here is our plane, and we have a package that is being dropped. So initially, this package has the same velocity as the plane, right? It's in the plane, it's moving forward at 152 meters per second. So that is our initial velocity, which is also just the initial velocity in the x direction. There's no vertical component of velocity initially. And this is 152 meters per second. We also are told that the plane is 2,100 meters above the ground. So this is our height. And we'll say this is the ground here. So this package is going to follow a path like this. Because of gravity, it gains a vertical velocity as well because there's the acceleration due to gravity. So it begins to fall, obviously. When you drop something out of a plane, it's going to fall down. But initially, our y component of velocity is 0 meters per second. So in the first part, we just want to find how long the package is in the air. So we know the height, we know the initial components of velocity, and we know that our acceleration is going to be g, right? So just in the y direction, our acceleration is g. So that's ay equals g. Now, given our kinematic equations that we have here, the best option is going to be the first one, but we use it for the y direction, so delta y equals v initial t plus 1/2 at squared. So let's go ahead and write that out. So delta y equals v initial y times t, and then we have plus 1/2 times the acceleration times the time. Now we know that this first term is 0 because v initial in the y direction is 0. So that turns our equation into delta y equals 1/2 a t squared. Now we want to solve for the time, so let's multiply both sides by 2, divide by the acceleration, and take the square root. So t equals 2 times delta y over a, take the square root. Now of course our acceleration here is g. So let's go ahead and plug in our values. So that's 2 times 2,100 meters. Now technically 2,100 meters is negative because it's starting off at 2,100 and its final height is 0. So it's 0 minus 2,100, but g is also negative, so those two negatives will cancel out. And we just have 2 times 2,100 over 9.81 meters per second squared, and we take the square root. This is going to give us a time of 20.7 seconds. So that's how long it takes for the box to fall and hit the ground. Now, we want to find how far away it lands horizontally. So that's our delta x, right? So this is what we are looking for, delta x. Again, just kind of using this first equation, delta x is going to equal v initial in the x direction times the time. Now, there's no acceleration in the x direction in free fall problems, so that term is 0. So delta x is just v initial x times t. And we are given that v initial is 152 meters per second. And our time that we just found is 20.7 seconds. And so that means it lands 3,146 meters away. Now, our other values have 3 significant figures, so we should probably round this to 3,150 meters. So it takes 20.7 seconds to land, and it lands 3,150 meters away from where the plane initially was, horizontally. So that's how you would do this type of problem. And this, of course, is ignoring any air resistance. Usually air resistance is ignored in these kinds of problems early on. So we are ignoring air resistance in this problem. So hopefully that was helpful, and let me know if there's any other types of problems you'd like to see in the comments.